So in this video we are discussing the problems on parallel RLC circuits. Okay, the formulas to remember, as I already told in the previous video, alpha equal to 1 by 2 RC, omega naught equal to 1 by LC, and then what is S12 formula based on alpha and omega naught, and you need to know all the three formulas for underdamped, overdamped and critically damped case. Three formulas you are supposed to know. Okay, in the case of series RLC and parallel RLC, these are all the important formulas. And one more formula is dV of 0 by dt formula also you should know. Okay, these many formulas you should know to solve this problem. Okay, so start. Okay, so why I am saying this is, first of all, whatever topic you are solving, first write down all the formulas at the beginning, so that will be useful for you to solve the problem. Okay, so here in the parallel RLC circuit, find V of t for t greater than 0, assuming V of 0 equal to 5 volt, I of 0 equal to 0. Initial condition is given directly. L equal to 1 Henry, C equal to 10 millifarad. Consider these cases, just consider three cases. Okay, that's not these cases, it is three cases, THREE. So R equal to 1.923 ohms, R equal to 5 ohms and R equal to 6.25 ohms. Okay, so first we will consider R is equal to 1.923. So find out alpha. So if it is an RLC series or RLC parallel, okay, whatever it might be, I need to find alpha and omega naught. That is the first thing we will do. So alpha equal to 1 by 2 RC. Okay, just substitute the values. R is 1.923 and C is 10 times 10 power 3, we will get 26. And then omega naught equal to 1 by root LC, 1 by root of 1 into 10 times 10 power minus 3, which is 10. Okay, we got what is alpha and what is omega naught. So in this case I can say alpha is greater than omega naught. Okay, I can say the response is overdamped. If the response is overdamped, okay, what equation I need to consider? I need to consider this equation, V of t equal to a1 e power minus S1, a1 e power S1t plus a2 e power S2t. So that is what I need to consider. Okay, so V of t equal to a1 e power S1t plus a2 e power S2t. So we need to remember this formula. Okay, we need to remember this formula, and then we need to find the roots. So what are the roots? For roots I need to use this S12 equal to minus alpha plus 7 as root of alpha square minus omega naught square. Alpha is 26. Okay, and substitute 26 wherever we got alpha, and omega naught is 10. So if I solve this, I will be getting minus 2 and minus 50. These are the two roots. Okay, one I can consider it as S1 and another one I can consider as S2. Substitute in this, we will get V of t equal to a1 e power minus 2t, a2 e power minus 50t. So this is what I got. Okay, now we need to find out the a1 and a2, the constants we need to find out. Okay, the constant we can find out by applying initial condition. By applying the initial condition, I am going to find out the constant a1 and a2. First put t equal to 0, v of 0 equal to a1 e power 0 plus a2 e power 0. So we will get v of 0 equal to a1 plus a2. That is equation number 2. Let us take and differentiate this equation number 1 with respect to t. So dv of t by dt can be written as this e power minus 2t. We will get minus 2 e power minus 2t, and then e power minus 50t minus 50 a2 e power minus 50 will get. Okay, now substitute t equal to 0. So dv of 0 by dt equal to minus 2 a1 e power 0 minus 50 a2 e power 0. This is what we get. Okay, so this is my equation number 3. So now we need to find out what is dV of 0 by dt. So for dV of 0 by dt, this is the formula, minus of V of 0 plus R I naught by RC. So minus of V of 0 is 5 plus R is 1.923, okay, multiplied by 0, I of 0 is 0, which is given in the question, by 1.923 times 10 power, so 10 into 10 power minus 3, which is minus 260. Okay, now substitute that in equation number 3. Substitute that in the equation number 3. Okay, minus 260 equal to minus 2a1 minus 50a2. Okay, so 2a1 plus 50a2 will be 260. I got two equations, two unknowns. I can solve it using calculator. I got a1 equal to minus 0.2083 and a2 equal to 5.2083. You can even use Cramer's rule for solving, but a simple method you can use calculator and solve this. You will get v of t equal to minus 0.2083 e power minus 2t plus 5.2083 e power minus 50t volt. Okay, next case, resistor value only will changes. Okay, so the formula is same, alpha equal to 1 by 2 RC, omega naught equal to 1 by root LC. Okay, so alpha is 10 and omega naught is 10. In this case both are same. We call it as critically damped. For critically damped, what is the formula? A1 plus A2t into e power minus alpha t. This is the formula we have to use, because alpha and omega naught are same. Okay, so for now find out the roots using the same formula. S12 equal to minus alpha plus or minus root of alpha square minus omega naught square. This part will become 0. I'll get only the real part, so minus 10 is the value. Now substitute in this, v of t equal to a1 plus a2t e power minus 10t. Okay, instead of alpha I can write 10. So v of 0 is given as 5, I of 0 is given as 0. Okay, to get a1, a2, we apply the initial condition. First apply t equal to 0. If t equal to 0, a1 plus 0 e power 0. So a1 e power 0 will be 1. So a1 will be equal to 5. Directly we can get this answer. So I got this value. Okay, this value is 5. Okay, next I need to find out a2. For that I need to differentiate one time. So if I am differentiating it, what I will get? a1 e power minus 10t we have. So my e power minus 10t will be differentiated as minus 10 e power minus 10t plus a2 t e power minus 10t is there. So you need to use u dv plus v du. So a2t, okay, e power minus 10t can be differentiated like this, minus 10 e power minus 10t, and then t will be differentiated to 1. Okay, t if I differentiate t I will get 1. So the second case is differentiation of t. So a2 times 1 e power minus 10t, that is what we got. Now substitute t equal to 0. dv of 0 by dt equal to minus 10 a1 e power 0 minus 10 a2 multiplied by 0 e power minus 10t plus a2 e power 0. So a1 value we know, so minus 10 into 5 plus a2, and dv of 0 by dt we need to find out using this formula. Minus of v of 0 plus r I of 0. I of 0 is 0. This part will be 0. So minus of 5 plus 0 by 5 times 10 into 10 power minus 3 will be minus 100. Okay, put it here. Minus 100 equal to minus 10 a1. a1 is 5. So minus 10 into 5 plus a2. So a2 equal to minus 100 plus 50. a2 equal to minus 50. So now substitute the value. v of t equal to a1 is 5 minus 50t e power minus 10t. It is critically damped case. So last case r equal to 6.25. So find out alpha 1 by 2 RC, we got 8. Omega naught 1 by root LC, we got 10. So in this case alpha is less than omega naught, which is underdamped. Underdamped will be, my roots will be complex. My roots will be complex, and I will be using this equation. V of t equal to a1 cos omega dt plus a2 sin omega dt. What is omega d? Alpha plus or minus j omega d. So it will be in this form. Okay, alpha is equal to 8 and omega d is equal to 6. So while finding the roots, s12 equal to minus alpha plus or minus root of alpha square minus omega naught square. Okay, I will be getting this minus 8 plus or minus j6. Okay, this is represented like this, alpha plus or minus j omega d. So alpha can be directly taken as 8 and omega d is 6. Now substitute the value of omega d and alpha. So omega d and alpha are substituted in this. a1 cos 60 plus a2 sin 60 e power minus 80. Okay, now consider the initial condition. Substitute t equal to 0, a1 cos 0 plus a2 sin 0 e power 0. Cos 0 is 1, so a1 times 1 plus 0 into e power 0 is also 1. So v of 0 is 5, so 5 is equal to a1, directly we get. So next, dv of 0 by dt formula is minus of v of 0 minus ri of 0 by rc. v of 0 is 5, ri of 0 is 0 by rc. So r value is given here as 6.25. Okay, and then c value is same as given in the question. Okay, 10 into 10 power minus 3. Substitute that, we get minus 80. Okay, so we got dv of 0 by dt equal to minus 80. Now differentiate this. Okay, this equation to be differentiated with respect to t. k1 cos 60 e power minus 80. Okay, so this u dv plus v dv, let us take. Okay, a1 cos 60 minus 8 e power minus 80 plus a1 minus sin 60 e power minus alpha t. Okay, e power minus alpha t. Like that I can write. So differentiate with respect to t, I will be getting this equation. Okay, substitute t equal to 0. Okay, my equation will be like this. Okay, so now dv of 0 by dt is equal to minus 80. Substitute the value and find the answer for a2. a2 we got as 6.667. Substitute in this equation. v of t equal to 5 cos 60 minus 6.667 sin 60 e power minus 80. Okay, thank you.